Remember the time when you had a fever? A thermometer was placed under your tongue to find out your body temperature. But how does a thermometer tell you your body temperature? We have come across the word heat many times in our daily lives. During sunny days, we say that the weather is hot today. And during winter, we rub our palms together to feel warm because it produces heat. So what exactly is heat? In earlier times, heat was thought to be a fine, invisible fluid called the caloric fluid that fills the pores of all physical substances. So, when a hot body and a cold body were placed in contact, it was believed that this caloric fluid is flowing from the hot body to the cold one. This is similar to the flow of water between two tanks connected by a pipe with different water levels. The flow stops when the water level in both tanks becomes equal. Similarly, it was believed that the caloric fluid flows from a hot body to a cold body till both of them reach the same temperature. It was Sir Benjamin Thomson, also known as Count Rumford, who was an American-born British physicist and inventor who performed an important landmark experiment that proved that the caloric fluid theory of heat is simply wrong. At the time, Sir Thomson was working as an Inspector General of Artillery for the Bavarian Army. While he was supervising the work at the Munich arsenal, he noticed that enough heat to boil water was being generated in the process of boring a brass cannon. Boring is a process in which a deep hole is made in a cannon. He devised an experiment where a blunt drill was being used to bore the cannon, and this process generated a tremendous amount of heat. And this made him think that an unlimited amount of heat can be produced in this way, which did not make sense because according to the caloric theory of heat, the water was getting heated because the caloric fluid from the brass cannon was flowing into the water. But what would happen if all of this fluid was transferred into the water? From where was this unlimited amount of heat coming from? It was these observations that made him propose a revolutionary idea that heat is not a fluid but a form of energy. That is, the work done by the drill is being converted into heat. In the beginning, I asked how a thermometer measures the temperature of a body. The tip of the thermometer contains mercury. When it is made to touch our body, heat from our body gets transferred to the mercury or alcohol in the thermometer. Once it is heated, the liquid rises up due to expansion and stops at a particular point where you can read the temperature. The term thermodynamics is derived from the Greek words therma, meaning heat, and dynamics, meaning force. Thermodynamics is the branch of science that deals with heat and temperature and their relation to energy and other physical properties of matter. Now, the thermodynamic description of a system does not deal with the microscopic constitution of matter, but instead deals with bulk systems. It is specified using macroscopic variables like pressure, temperature, volume, etc. Things that we can measure directly or feel through some perception. They are measurable, we can quantify them. For example, consider the case when a bullet is fired from a gun. As the bullet is fired, its kinetic energy is changing, which means that it has a mechanical kinetic energy. Its state is changing. While mechanics deals with the study of motion of the bullet as a whole, under the action of forces and torques, thermodynamics deals with the actual energy changes happening inside the gun and the bullet. Now suppose the bullet is hitting a wooden plank. Due to the friction with the wood, the heat of the bullet, the wood will start to burn in the surrounding region. So this is happening as a result of the conversion of kinetic energy from the bullet into heat energy, which is setting the wood on fire. So thermodynamics teaches us the temperature change of a bullet. It is the result of internal motion inside the bullet and not the motion of the bullet as a whole. Just as this kettle could be sitting in your kitchen or inside a plane going 1,000 kilometers per hour, but the thermal energy of this kettle would depend only on the internal random kinetic energy of the water molecules inside it. Now, you may be familiar with the term equilibrium. We will enter the world of thermodynamics by tackling the concept of thermodynamic equilibrium in the next lesson. So let's summarize what we have done so far.
Manorama Horizon. Learning made simple.